All right, good morning. Sorry it's so late in me getting this last unit done. I'm actually going to do a few more units too. Just want to cover as much as we possibly can before the end of this course in applied math. So this is unit 26. This is areas of common polygons, and this is actually very simple things, just little formulas. And your book has all of the formulas. But I have them written down here too. Unit 26 starts on page 568 in your book, and all the formulas are there. All the examples I'm doing are from those pages. So again, you should be taking notes while you watch this and writing these things down as if you're in class. So our first formula is the area of a rectangle. Find out how many little squares are in this rectangle, how many square feet of carpet you might need, or square yards of something you might need to lay out in a floor. So the formula for the area of a rectangle is length times width. So if we look at page 569, this is actually an example from the book. We've got a building floor. I'm just going to move that book right here. So we've got a floor plan is shown here, and we'd like to find the area of the floor plan. So this isn't just one big rectangle. We've got a couple of different options what we can do, although they tell us exactly what they want us to do here. We didn't have to do that. We could actually find the area of the big thing and then subtract out these little areas here if we could find those. I don't know if that's possible. It looks like it might be. But they want us to divide it up like this. So what we're going to do is we are going to find the area of this using these three shapes. So basically we have three rectangles, and the first rectangle number 1, we can tell by the picture is 42 by 16, and we can tell that rectangle number 2, the second one, is in here, and that is going to be 22.5, and these are all feet. The single mark means feet. And trying to figure out how long this is. If I look at the picture, I can see that that whole length is 72 feet. And then the third one, the third rectangle, kind of overlaps here. And this is 44.75, and this little section is 18. So we have three rectangles. So the area of the first rectangle, the area is going to be length times width. Length times width. Quite honestly, it doesn't matter which one is length and which one is width, as long as you've got the two measurements. 42 times 16. And then the area of rectangle 2 is going to be 72 times 22.5. And the area of rectangle 3 is going to be 44.75 times 18. And we're going to get all of those answers, and then when we're all done, we're going to add them up. So the first rectangle, it ends up being 672.0 feet squared, or square feet. Anytime you're dealing with area, if you notice, this is a feet and this is a feet, so feet times feet is feet squared. Any area measurement is going to be something squared. Centimeters squared, feet squared, inches squared, yards squared, whatever. It's always squared. That's how you correctly label an area calculation. So 72 times 22.50 is 1,620 feet squared, and 44.75 times 18 is 805.5 feet squared. So if we add all those up, then our final area is 3,098 feet squared, and that is rounded. So rounded to the nearest whole number. All right, so now the next shape we're going to find the area of is a parallelogram. And a parallelogram basically is like I would call it like a rectangle that kind of got slanted. It got the bottom stayed the same, and the top got blown to the side a little bit, but both of these are slanting at the same angle. And this height, the height that we have for our parallelogram is not the side. Okay. The nice thing about rectangles and squares is that when you find area and volume of like a rectangular solid, if they're straight up and down, that makes it nice. But as soon as you put them at an angle, that puts the height at a different place, kind of like a triangle. So we need to know the height and the base still. The area of a parallelogram is still the base times the height. The base is the same as the length, but they refer to it as the height now because it's not just a side. It's not a measurement of a side. The reason we refer to area of a rectangle or square as length times width is because you're actually using a side. But with a parallelogram or anything like a triangle, your height is not a side, so you have to make that clarification. So again, this is still a pretty easy one. We're going to look at an example. This is on page 574. This isn't actually an example, it's actually just a problem. And we're going to look at number 17, and we've got a picture in the book. I'm looking at the book. It's a cross-section of a piece of tool steel, and it's the shape of a parallelogram. So this is the picture that we have, and it goes back, and this just shows it's like three-dimensional, okay? But we're just looking at this end of it. And we know that this slanted part is 1.25 inches, and we don't know that part though. That's the part we actually need to know. And this is your base. That whole thing is your base, and that whole thing is your height, but we don't know that right now. We know that this whole thing is 1.50 inches. We know from here to here is 0.50 inches, and we don't know this. Okay, and we actually need to know this, and we need to know the base. So in order to find this area, the area is going to be the base times the height. We've got kind of a big problem here, and this is where we have to utilize things like the Pythagorean theorem, because what you notice here, this is a right triangle. In a parallelogram, the height is always a line that goes perpendicular to the opposite side. So this is a right triangle. So we're just going to look at this right triangle first of all. And so far that's the only side that we know. Okay, I've just kind of pulled this out. We really want this side right here, because if we get this side, then we can actually finish our area, because we know the base is 1.50 inches. And if we just could know this height, then we can plug that in, multiply, and have our area will be all done. Okay, so how am I going to find, first of all, I need to find this. So this side, well, if this is 0.5 and this whole thing is 1.5, that means this is 1 inch. So I know this is 1 inch and this is 1.25 inch. Now I can use my Pythagorean theorem. My Pythagorean theorem says that a squared plus b squared equals c squared. Well, the first thing you have to do is decide what's the c. The c is always the one opposite the right angle, so c is 1.25. So 1.25 squared equals, now the other two, it makes no difference which one's A, which one's B. These are both, doesn't matter. So I'm going to make 1A and H into, I'm just going to leave that H. B is going to be H. So I've got 1 squared plus H squared equals 1.25 squared. So to solve this, I'm going to square 1.25, take it times itself, and that gives me 1.5625. I do not round. And 1 squared is 1, and then I have h squared still. I need to get h squared by itself, so I'm going to subtract 1. So then I'll get h squared equals 0.5625. And then to get rid of the squared, I'm going to take the square root of both sides. So the square root of 0.5625 will give me the height, which is 0.75. So now I know that the height is 0.75, and so I can just plug it right in there, times 0.75 inches. So 0.75 times 1.5 gives me 1.125, and this would be inches squared. So we had to use something that we learned from a previous section and in order to find the actual area. All right, so now we're looking at a trapezoid, the area of a trapezoid. A trapezoid is like basically it's a rectangle with two triangles. Here's your like rectangle in the middle, and you've got two triangles on each end, but there's a nice little formula we can use. The height in the trapezoid is the same as the height in the parallelogram. The base, it actually has two different bases. It has a base on the bottom and a base on the top. And so the area of this can be found by taking 1/2 of the height times the sum of the bases. So we're looking at page 579, number 20. And we've got a cross-section of a concrete slab, looks like this, and a retaining wall, and it's the shape of a trapezoid. Again, they show us that it's three-dimensional, but we're only interested in this here. They tell us that this height is 12 feet 0 inches, and they tell us that going across here is 10 feet 6 inches, and this little thing up here is 4 feet 6 inches. So we would like to find this area, and it kind of works out nice because this side here is the height because it is a right angle. So we've got the height, so that's the height, and then the base 1, this is base 1 at the top, this is base 2, and that's all we need. So we can actually just plug these things in. Now the thing is, 10 feet 6 inches, you know, we can leave it in terms of feet and inches, that's fine, we'll see what happens. We could also change it, 6 inches is half a foot, so you could also write this as 4.5 feet, and that would be 10.5 feet. That's another way you can do this. Alright, so the area would be 1/2 the height, which is 12 feet. So half times 12, and then times the base 1, which is 4 feet 6 inches, plus 10 feet 6 inches. So let's see, half of 12 is 6. I can multiply those two numbers out there. 4 feet 6 inches plus 10 feet 6 inches is 14 feet 12 inches. But that actually, 14 feet 12 inches is actually just 15 feet. So 6 times 15 is 90, and that's going to be feet squared. That's the area. Alright, the area of a triangle, it's like half of a rectangle, or half of a parallelogram. Base times height, and multiply it times 1/2. So we're looking at page 580, number 50, or number 1, and we've got this triangle here. Mine is a little bit different than the one. They tell us that this here is 19 centimeters, and they tell us that this here is 22 centimeters. And the reason this is actually the triangle here. This is the triangle. This is just representing the height because you need how tall it is. It has to be a right angle. So this is like you had to extend the bottom, the base of the triangle, but this is still the whole base right here, and this is the height. So to find this area, we're just going to take 1/2 times the base times the height, and the base is 22 and the height is 19. So half of 22 is 11. 11 times 19. So the area of this is 209 centimeters squared. So there's other ways you can find areas of triangles. They have another interesting formula actually called Hero's formula. And Hero's formula is, I don't actually teach this until trigonometry in high school, so you're learning something kind of ahead of the game here, really. This is called Hero's formula. That's just the Greek mathematician who figured it out. And if you have a triangle and you know all 3 sides, which is sometimes, you know, you only know all 3 sides and you really don't have any way to find this height here, this altitude. So you don't know how to find that, and that would take a lot of work. So a nice way you can find the area is using Hero's formula. Hero's formula takes the sum of all the sides and multiplies it times 1/2 and gives it a value called S. And then they take that S and they take that value and multiply it times that value minus the first side, times that value minus the second side, times that value minus the third side, and they take the square root. So we're going to look at page 581. We've got this picture here. And we've got this out. Mine is not drawn exactly the same as theirs. This is K, this is J, this is 7.84, and this is meters. This is 5.12 meters, and this is 10.2 meters. So we know all 3 sides, and we would like to find the area, so we're going to find S. So S is equal to 1/2 times 10.2 plus 5.12 plus 7.84. Okay, so when we find all of those, S ends up being 11.58. So now we're just going to take 11.58 and subtract one side, so 10.52. First we're going to take the formula. A is the square root of, we're going to take 11.58, that's what we found for S, we're going to take S minus the first side, so 10.52, there's our first side, and then 11.58